This is an example problem where we get to use some of the theorems that we've gone over here recently.
That's the loveliest thing I've ever heard.
Well, I'm glad you feel that way. Well, here's what we're going to look at. First, I'm going to say find the derivative with respect to t of the vector r of t, which is 1 over ti plus 1j minus ln of tk. So how would we find such a derivative? Well, the derivative of 1 over t is negative 1 over t squared. You can think of it as t to the negative 1, but I'd be reviewing Calc 1 if I got into more detail. The derivative of 1 is 0, and the derivative of ln of t is 1 over t. So what we would have then for r prime of t would be negative 1 over t squared I plus 0j minus 1 over t k. And we also want to find the derivative of u. By the way, here's that verified there. If we also want to find the derivative of u, then the derivative of cosine is negative sine, the derivative of sine is cosine, the derivative of e to the negative 2t is negative 2 times e to the negative 2t. And so, I think I said that wrong. The derivative of negative e to the 2t is negative 2 times e to the 2t. Now I said it right. And so we can verify that. Here's the derivative of cosine is negative sine, the derivative of sine is cosine, the derivative of negative e to the 2t is negative 2 e to the 2t, and there we have the derivative of the vector u. Okay. Proceeding. What about the derivative of the dot product of r and u? And we could go back here and say, why, it's the r of t times the derivative of u of t plus the derivative of r of t times u of t, and that should be enough for us to do this. And let's see if in fact it is. So the r of t is this vector times the derivative of u of t, which is this vector, right? Actually, I guess I should say time. When I say dot, I should be specific. Times, I should say which particular type of multiplication is the dot type. And so we want to multiply this 1 over t times negative sine of t, this 1 times cosine of t, and add to that, I say add because it's negative times a negative, so add to that 2 ln of t times e to the 2t. And so, and then we also want to say plus the derivative of r of t dotted with the original u, so it would be negative 1 over t squared times cosine t plus cosine t times sine of t. Well, wait. I'm doing the wrong thing. It's negative 1 over t squared times cosine t plus 0 times sine of t minus 1 over t times e to the negative 2t. So here's all that written out. Here's the here's our r, here's our du, here's our du, or here's our u rather, I'm sorry, and here's our dr. And these are all dot products. So when you simplify this dot product, it's this times this plus this times this, this plus this, just this much, times this, just this. And I hope you can see all that part in there all right. So here's that, and that. And then for this other part, since we have a 0j as part of the dr dt, and so we dot cosine t with negative 1 over t squared, that's here, and the sine of t times 0, and that's non-existent because it isn't, and then this times this, they're both negative, so positive e to the 2t over t. So there is our dot product.